Good morning. This presentation is by Waterman Valve. It's in regards to our fabricated rectangular butterfly valve operation and then maintenance training. There's an aerial view of our plant here in Central California. This is January 2022. It's in response to a project in Winnipeg, Manitoba, Canada, project number ME28936-D. The person that prepared this presentation, his name is Emmanuel Webna, a professional engineer here in the States. He has 6 years experience in valve design. He provides all the operation and maintenance training. He has 5 years experience in structural and civil engineering. This course will include the purpose of the training, definitions and familiarization with the terminology, operation, troubleshooting, preventative and corrective maintenance, and safety precautions. There'll be a question and answer period at the end. However, this not being a live presentation, I'll just try to come up with some of your typical questions might have. The purpose of the training will include familiarization of the butterfly valve types and the main components, identify parts which require periodic inspection, how to perform periodic maintenance, valve operating procedures. Note, the electrical motor operator and steps on how to set, open and close limit switches will not be covered in this presentation. They'll be under a separate training. Most frequent causes of excess leakage and troubleshoot procedures and safety precautions. Let's get started. The purpose of the training continued in definition is to provide information on the correct procedures for adjustment, operation, and maintenance of Waterman fabricated butterfly valves. Description and application of butterfly valves. Major parts of the butterfly valve are going to be covered: operator mount weldments, frame weldments, cover weldment, design philosophy and theory, design head, operating head, the difference of the two, operating torque and change pressures at various opening angles. Description and application of the butterfly valves. It will include butterfly valves, are also known as quarter turn valve or rotary operation valves, and in some cases butterfly gates. Flow is controlled by positioning the closure member between 0 and being considered closed and full open 100%, which is approximately a 90-degree position. They're available in 4-sided seating models for orifice or inline mounting and 3-sided models for channel mount units. This training is solely prepared for 3-sided seating models. Description and application of butterfly. Commonly used where low headroom prevents the use of conventional sluice or slide gates, where flow regulating or modulating is a requirement as well. Advantages of using butterfly valves: there are watertight performance in either direction, both seating and unseating heads, the acceptance of maximum heads of water on either side. They can be operated with small number of turns required to achieve the same effect with a slide gate in the same service. More description of application of butterfly valves. Advantages of using butterfly valves: ease of installation. Butterfly valves are factory adjusted and tested prior to shipment and should not require any field adjustment at startup. They're shipped as one unit, one single piece that can just be installed as one unit. Applications can include sewage treatment plants, water filtration projects, cooling tower basins, power plants, and many other water and flood control projects. Here's a diagram of a typical Waterman butterfly valve. On this project, they're very similar in design to this in that they're very narrow and very tall. The main parts of the butterfly valve include an operator, the torque tube and bonnet or the extension, the frame structure, and the cover. The operator is a large gear-driven quarter-turn actuator or operator. This, in your case, it's an AMA worm gearbox. The operator may be discussed in depth on a different topic. Here are the pieces of your extension, what we consider the stem, the operating stem. Operating mount and stem assembly includes taper pins for connection at the top, your thrust plate, your operator support, your torque tube, stem 1 gearbox, stem 2 goes to the valve. So you've got two different stems on that torque tube on two ends. And you've got a bushing on the bottom end, along with a thrust collar that helps absorb the forces required to open and close. The access panel is an inspection cover. We've removed it there so you can see clearly what's going on. The torque tube itself, stem number 2 and stem number 1 are shown in their design. The operator mount weldment, the upper stem assembly, zoomed in. So you have the gearbox, the worm wheel, the internal splines, the spline plugging or plug-in coupling, and then of course the valve shaft. And in this example we have a key. Here's a better description of the upper mount assembly. You've got that bushing retainer plate as shown previously, the thrust ring disc pin, and then of course the torque tube. The torque tube is something that is better shown down below there, but you have the bushing and your thrust bearings. Now here's the torque tube split in a sectional view. You've got your torque tube sleeve and the torque tube sleeve on the top. So those are the two areas that those previously mentioned stems are pinned in place or bolted in place. Here's the operator mount lower stem assembly. Shows the lower stem, which was referred to previously as stem number 2, and of course the bushing and the end cap bottom stem cover plate. This is at the very bottom of the valve, and that's cover plate prevents any debris from entering our pin area. The lower stem is a tapered pin that's actually connected to the vane or cover. There's your O-ring for seal. Here's a good description of the whole frame assembly. You've got the frame assembly isometric views here. You've got the side channel frame, the top channel, the side seat seal area, and your bottom channel. Here's your detail A that shows the top area where the lift is mounted or the extension torque tube is mounted. And then of course detail B down below shows your lower bushing housing that we just looked at in the previous slide, and the seats on the bottom seal. Notice the taper to the seat allows the rubber seals to travel up onto the seated area without being damaged. The cover assembly. The skin plate or cover has a smooth side on one side, and then of course your strong ribs on the back side that may or may not have a skin plate over them as well that's removable. The bottom seal and your side seals travel around all three sides. If it's not a top seal like yours, it's just a three-sided. Notice the rubber or the neoprene seal in the middle picture there. It shows a dual contact zone, and that's how we reduce the leakage down to 0. The upper central tube that cover horizontal reinforcing ribs, and the lower central tube, and that's that connection to those stems we talked about previously, stems 1, 2, and 3. Where you find the design head and operating head values, if you look at your drawing, they're found in the bottom right-hand corner in the notes section. Notes, unless otherwise specified, is how we talk about it. And we'll zoom in here. That's your operating design head, and operating head can be found in that area of the notes. This is what it looks like zoomed in. Notice in your job that we have a design capacity of 6 foot ahead, 1.85 meters, and of course the operating head is the same in this case. Oftentimes the operators are sized for a larger or lower head than the actual design. There's your design head, there's your operating head, and then the shows where on your plan drawings where these gates were located. The design head, how do we come up with that calculation and what effect does it have? It's used to design the slide. For maximum deflection, it will not exceed 360 is the acceptable deflection. The bending stress not to exceed a half the yield stress capacity or 1/5 the ultimate, whichever is lesser will govern the design. The design head is calculated with a very complex formula shown in this picture on the right, and it's used to design precast epoxy anchor strength to withstand seismic hydrodynamic forces and hydrostatic pressures. It's used to design the stud strength for thimble mount valves. We use this similar formula for the embedded valve or the embedded thimbles for mounting if that's the case. Note that embedded type channel mount valves don't require anchorage design due to the nature of the load distribution built into the thimble. Thimbles are cast in place in your concrete wall. The operating head is used to size the operator. The main objective is understanding minimum torque required to operate the valve is to help you solve any issues associated with high resistance that you may have encountered during emergency or manual operation. It will be discussed more in detail on operational section of this training. The operator is designed to open the valve under full operating head condition and close the valve under operating head or less. There are two torque components to evaluate minimum required torque to operate the butterfly valve: passive or friction based, active or dynamically generated. There's the formula we use. This is probably a little more detailed than most of you want to know about, but the operating torque from fully closed position 0 degree is calculated as, and you can follow through there, it has your total torque, and it breaks down the three different components of how we establish the torque. It's also known as the breakaway or the brake torque. The operating head, the torque required to open the valve from closed position, this is continued from where we were at, where bearing friction torque, which is noted as TBF, then pressure of the gate area, the radius of the shaft, and the coefficient of friction, the drag of the rubber seats on your stainless steel seats, rubber seals on stainless steel. Packing and hub seal torque, there's lots of different factors to what increases the torque on these valves. The unseating torque, the equation derived from rectangular butterfly valve talks about the seating coefficient, the tightness of the seal on the seat on the seal frame. And there's the calculation. In general, passive or friction related resistance is constant for a given valve or are directly dependent on the differential pressure, which generally considered to be essentially the same magnitude in either direction of operation, opening or closing, except for seating and unseating. Seating and unseating torque may be evaluated separately or considered the same when differences are small. The operating head, case number 2, torque required at different angles of opening torque. That's under heavy flow conditions. It can have a big effect on your coefficient of friction by your resistance of your flow. Again, taking into consideration the different causes and effects, we have different calculations that are used. Here's a question. If you encountered a situation where excessive force is required to operate the gate, what are the factors that causes this problem? What are the constant factors? Think about it. Your rotation is a constant factor. The rubber traveling up onto the seat can be an increased factor or a constant factor depending on where you are in travel. If you're in the middle in a full open position and you're having resistance while you're trying to close it, something is going horribly wrong. How much force is excessive? What are the corrective measures? These will be covered in the operation portion of this training. The operating head discussion is the minimum torque required to operate the valve versus angle of the opening. This graph below is prepared to specifically for this project, the butterfly valve for a discharge rate of 1,995 liters per second, or roughly 69 cubic feet per second. It shows the increase in torque that is achieved to really get at the seat and how it breaks away, and it has a slight increase in torque curve and then slowly decelerates to the full 90-degree opening. And if you're closing it, it's the exact opposite. You can see at a full 90, it's relatively full flow, no resistance, and then it increases as you're closing it into a high resistance as it's seating itself, then it drops off as it is in the seating position until you get to a fully closed position. The operating head, discussion of minimum torque required to operate the valve versus the angle. This table is prepared especially for this project. The butterfly valve for a discharge rate, again, of the 69 cubic feet per second, or the 1,995 liters per second. There's the table that we use. Imperial unit system, you guys understand probably better than I in Canada what the conversion rates are. So there's a conversion in the imperial unit system that you're familiar with. Check marks prior to operating the valve. Initial operation procedures, setting the open and closed limits on your manual operator, setting torque limits are all going to be included in this section. Levels of operator control systems, manual hand wheel operation, adjustment of the shaft packing are all going to be covered. Check marks prior to operating the valve, continued. Notice the valve on the right. Again, very similar to what you guys have there on this Manitoba project. Check the alignment of the lift and stem. Make sure everything is truly in alignment. Notice the red line. Should be able to draw directly from the center of the geared operator right down through the center of your pivot shaft number 3. The alignment of the stem connected with the operator, stem 1, stem connected at the top of the Discover, stem 2, and the bottom stem connected with the frame, stem 3, is very crucial to attain smooth operation and reduce valve component damage during operation. Remove any shipping stops on the gates. Periodically, we ship them in the opposite corners, top right, bottom left corner, to prevent rotation and shipping. If done previously, or if the gate stem was set sometime after installation, thoroughly clean and lubricate your stem threads. Lifts are factory lubricated and do not need lubrication at the time of installation. Understand the references and symbols below. There's typically your geared operator. Sometimes these will ship separate from the valve, so don't be surprised if you're watching the contractor install this during the process. You have the input shaft, or where the hand wheel is located, or the electric operator is located. Output drive, refer to the previous slide if you have a question about the output drive. The symbols on the top, symbol for open is a simple line that is open inflow, and the symbols for closed is with your line crossways inflow, or simulating a closed pipe. Notice there's 2 places, whether it's clockwise or counterclockwise direction, you've got 2 closed locations available. Alma worm gearboxes are part turn gearboxes, converting a rotary movement in the hand wheel and the input shaft into a part turn movement at the output drive. The setting sequence recommendation for butterfly valves: set and stop closed first. So always think about the closed position first. That's where you set. The end stop setting is generally performed by the valve manufacturer. Waterman sets this prior to shipping. The internal end stops limit swing angle and protective valve against overload. Sometimes the contractor has to adjust the mount of the gearbox, and then these closed positions on the gearbox have to be reset. In general, only one end stop closed must be set, since the swing angle valve is already set for 90 degrees in the factory. Close the valve completely, check for proper closure. Notice the seat on the left hasn't traveled, the seal on the left hasn't traveled up onto the seat, and in the middle it's traveled up into the closed position. So this is the open position, this is the closed position, and those there are your feeler gauge, can be checked from either side with a 2000 feeler gauge. You just insert it in there and see if it passes through. If it passes through, you've got a problem. It can be simply adjusted by tightening that nut on the left-hand side, and that'll squeeze the rubber out for better contact. Those nuts are located every 4 inches, and so you pick the one most closely adjacent to your gap that you've encountered. Setting open and close limit switches or limits on your gearbox. Remove the 4 screws that are located as number 1 at the end stop number 2. You don't remove the end stop, you remove those and you just simply turn it until it hits its stop, and then back it to the closest hole alignment and replace your 4 bolts. Turn the valve via hand wheel to position closed. Check whether the stop rotates simultaneously. Otherwise, turn the end stop clockwise to the full stop position by hand. Then replace your bolts, and your close limit switch or limit stop is set. With mounted multi-turn actuator, turn the end stop counterclockwise by 1/4 turn. This ensures the gearbox end stop cannot be approached during motor operation if a multi-turn actuator is mounted, and the valve can close tightly for a torque seating. In the case of the four holes at the end stop do not match the 4 threaded bores within the housing. Remove the end stop until it disengages from the gear teeth and replace in its correct position. Fasten the screws clockwise or crosswise with a tightening torque of 200 Newton pounds. If the gearbox is equipped with a pointer cover, check in the alignments of the closed symbol. That's something we covered in the previous slide, that big arrow indicator. You want to make sure it's now pointed to the closed symbol. Performing all commissioning settings and test run prior to the motor operation. This is a critical gear setting that should be done in conjunction with your electric operator limit switches being set. Adjustment and shaft packing. Remove the cover plate, item number 14, for access to packing. Adjusting retaining bolts, item number 29. Remove any accumulated moisture. These numbers are referred to in your drawings, your submittal drawings that you have on hand. Tighten the bolts in 1/3 to 1/4 turn increments in clockwise sequence, making sure all bolts receive equal increments. Bolts should be snug but not over tightened, as this will bind the shaft, making operation difficult. Note, after tightening, leakage continues around the shaft. Replace the packing material. Contact a factory for replacement material. There's your drawing, and it shows the parts that we've talked about accordingly. That is actually a picture of one of your valves ready to ship from our California plant. And there's another angle with your Rotork operator mounted on the Rotork gearbox. We've been referring to AMA in the previous slides. They are very similar in design. This one has mechanical stops that are built into those two bolts that come out to the right-hand side. Those are your adjustments for open and closed stop positions. And those are factory set as well, so they shouldn't be something you have to bother with. Troubleshooting. Excessive leakage around the seating areas. Excessive effort is required to handle the hand wheel or crank, or the electric motor operator is malfunctioning. Excessive leakage around the seating areas can be solved by butterfly valve seals are factory adjusted and tested prior to shipment and should not require field adjustment at startup. If leakage occurs, adjustment can be made as follows. Seal adjusting screws are accessed from the upstream, the flat side of the valve, like I mentioned in a previous slide. Adjustment requires an Allen wrench for round head seal retainer screws, or just a standard 7/16 wrench if they're nuts. If you have excessive leakage around the seating areas, apply water pressure against the downstream side and observe peripheral seal on the upstream side. Be sure the valve is completely closed. Leaks can be stopped by tightening the seal adjustment screws immediately adjacent to the leak that was discussed earlier. The bolt and rubber back sealing washers should be replaced. Apply silicone sealant to the bolt head and surface around the bolt hole. Use anti-galling compound on bolt threads and nuts throughout. After threading in, allow silicone to set before retesting. Excessive leakage around the seating area. If the seal continues to leak, drain water and open the gate. Inspect the seal and seat for damage. If there is damage, contact the factory for further instructions. Make sure that you remove any debris that may be attached to your seat, such as grout. Never open or close the valves with dry seals. Lubricate with silicone grease if unable to submerge in water. Another caution, do not over-tighten the seal adjustment bolts. Always use anti-galling compound on seal as mentioned previously, adjusting bolts prior to reinsertion after removal. More troubleshooting. Excessive effort is required on the hand wheel. The main cause of this is improperly lubricated or damaged valve stems. Valve packing gland is too tight. Improperly lubricated valve. Stem nut is too tight on the valve stem. Faulty or damaged valve or parts. The remedy for these can include ensure the stem is lubricated as recommended, check for foreign material being jammed in the seat, a generous application of penetrating oil or grease, contact Waterman valve for replacement. Troubleshooting continues. Electric motor operator malfunction. The main causes can include geared limit switch fails to stop the valve travel, unable to operate the unit by motor, could have electrical problems. Remedy for the geared limit switch, control wiring and motor reversing contact, Geared limit switch settings. Setting the rod to see which has been if it has been backed off after each side of switch has been set. Remove the limit switch gearbox cover and inspect for damaged or broken geared teeth. Proper maintenance. Preventative and corrective maintenance. Maintenance and lubrication. Lift and stem maintenance. Cycling the valve. Field painting. Replacement of seat for butterfly valve flanged or wafer. Spare parts and parts for replacement. These will all be covered now. Lift and stem maintenance. Depending on location, the number, cycle of operation or frequency, and operating conditions, the stem thread and lift nut thread shall be lubricated, and periodic check is required to ensure enough amount of lubricant is remaining. Operating difficulties and premature failure will result if the stem thread and lift nut are not lubricated periodically. This is very important. Clean threads and remove any foreign material before applying lubricant. Inspect the stem threads, the lift nut threads for wear, check degree and wear on the threads. Other than periodic cleaning as required to maintain smooth operation or painting to maintain appearance, no maintenance is required on your butterfly valves. Change of grease is performing during maintenance, generally after 4 to 6 years of modulating duty, constant use, generally after 4 to 6 to 8 years of, if operated frequently, open and closed duty, generally after 10 to 12 years if operated rarely, open and closed duty, such as 10 to 12 times a year. It is highly recommended to exchange the seals when changing the grease. No additional lubrication of the gear housing is required during this operation. Cycling the valve. Gates may require occasional cycling to alleviate sticking. Cycling at minimum 30-day intervals is recommended. Other than periodic cleaning is required to maintain smooth operation or painting to maintain appearance, no maintenance is required for these butterfly valves. Preventative and corrective maintenance. Field painting. The following procedures should be followed for field painting. Equipment supplied with primer only or for recoating installed equipment for continued maintenance and protection. Before any sandblasting or painting, all seating and wedging surfaces should be properly protected by masking. Wedges, if any, should be removed from the gate. All machine surfaces not primed on gates and attachments should be properly protected by covering or masking. Prepare all prime, painted, or previously painted surfaces in accordance with the coating manufacturer's specification prior to painting. Field painting. After painting, remove all masking and thoroughly clean all seating and wedging surfaces. Replace cover weldment if it has been removed. If valves are not installed, replace shipping stops. Coat all machine sliding surfaces with grease of a type allowed by local or project specifications to be environmentally safe. Safety. Here are some safety precautions. Emergency operating instructions, manually operated valves, electrically operated valves, safety instructions in general. Some precautions. Manually operated valves. Manual valve operators have no emergency procedure. Electric motor operators may be operated manually in the occurrence of an electrical failure by moving the handwheel clutch lever arm in the direction indicated by the operator housing. Rotating the handwheel will move the gate open or closed. The handwheel clutch will automatically disengage when the unit is energized electrically. More safety instructions. Do not apply water pressure above the gate capacity listed on your engineering drawings. Keep your hands and clothing, tools, etc. away from any moving gate. Do not work or loiter beneath an open gate leaf without providing stop blocks and removing electrical power from electrically operated gates. Remember, lock out, tag out. That's the rule of safety. If the electric operator must be dismantled for service purposes, it can be isolated from the mains without having to remove the wiring at the electrical connection. Additional safety precautions. Greases and oils are hazardous to water and must not be released into the environment. Arrange for controlled waste disposal of any disassembled material or for separate recycling according to materials. Observe the national regulations for waste disposal. Questions and answers. This would be a time that I would answer any questions. Please keep the Waterman valve number handy and don't hesitate to call a factory expert if you have any questions or concerns.